Welcome back to Bodily Feud, everybody. I'm your man, Cell Archie, and we're joined today by our healthy cells and a new contestant, the cancer cells. Red blood cell, why don't you start us off?
I'm red blood cell, and I'm joined here with neuron and lung cell, and we make up the healthy cells. As healthy cells, we regulate the body and keep it in homeostasis.
We divide when necessary and respond to the body's regulatory system.
When we're no longer functioning properly or no longer needed, we undergo apoptosis, also known as cell suicide.
May they rest in peace. On to you, cancer cells.
Finally, we're Team Cancer Cells. I'm carcinoma, this is sarcoma and melanoma, and we're able to divide uncontrollably, we can metastasize, and we also ignore regulatory signals.
We also avoid apoptosis, which allows us to accumulate mutations.
And this allows us to spread and invade throughout the body.
Nice. Alright, let's get this game started. Give me carcinoma and red blood cell. As usual, we have surveyed 100 cells in the body, and we have the top 4 answers on the board for you. The question for you today is, the hallmarks of cancer are...
Evading growth suppressors?
Correct. Mutations in tumor suppressor genes prevent the proper function, often leading to uncontrolled growth and unregulated transition through the cell cycle despite the cell carrying DNA damage. Healthy cells, this one is yours. Alright, on to you, neuron. What is another hallmark of cancer?
Resisting cell death?
Resisting cell death.
Yay!
Correct again. Cancer cells can bypass cell death signals that normally cause apoptosis in damaged or faulty cells, allowing them to survive and accumulate. Lung cells, your turn now. Give me another hallmark of cancer.
Ooh, is it deregulating cell energetics?
Deregulation? Yes! Cancer cells can reprogram their energy metabolism to exclusively use glycolysis to facilitate the formation of more useful intermediates and to function under the hypoxic conditions present in many tumor cells. Alright, back to you, red blood cell. Give me one more hallmark of cancer.
Evading immune destruction?
See? Correct. Cancer cells can immobilize immune cells, recruit immune suppressors, and avoid death signals by natural killer cells. Healthy cells coming in strong with 4 correct answers. Now for the next round. Let's get into a more specific type of cancer. Top 4 answers on the board. Adenosquamous carcinomas are known for what?
Being easily treatable.
They are not easily treatable. While there are a few treatment options, adenosquamous carcinoma is more difficult to treat than other types of cancer.
Yeah, you can't get rid of us that easy.
Cancer cells, you have a chance to steal. Adenosquamous carcinomas are known for being...
Rare.
Rare, that is correct. Team cancer, it's yours. Okay, melanoma. Adenosquamous carcinomas are known for being what?
In the lungs?
In the lungs? That is correct. It is known that more than 50% of adenosquamous carcinomas are in the lungs. Now, carcinoma. Adenosquamous carcinoma is known for being...
I'm gonna say aggressive.
Aggressive. Correct. This is one of the most aggressive forms of cancer present. Since it's difficult to treat, it poses serious challenges for patients and society. Okay, one more. Adenosquamous carcinomas are known for being...
Adenosquamous carcinomas are tumors that contain adenocarcinoma cells, which form gland-like structures and secrete fluid. They also contain squamous cells, which are flat, thin cells that line epithelial surfaces, which means there's 2 cells, so 2 cell types.
2 cell types. Correct. Congratulations, cancer. That lots of catching up to do for healthy cells, huh? Circling back to our hallmarks of cancer, there's a particularly sneaky way cancer cells survive, by evading the immune system. We surveyed 100 cells, and the top 3 answers are on the board. Now, how does cancer evade the immune response?
They have. Cancer cells reduce the amount of MHC class 1 molecules on their surface. We normally present protein fragments on our MHC class 1 surface so that cytotoxic T cells can inspect them. However, cancer cells do not present these MHC class 1 molecules, and therefore cytotoxic T cells cannot recognize them, so they can continue to divide and divide and divide.
That's very sneaky. Let's see what the survey says. And correct. MHC1 are downregulated in 40 to 90% of tumors, including non-small cell lung cancers like adenosquamous carcinoma. Okay, on to red blood cell. How does cancer evade immune response?
So TGF-beta is a cytokine that regulates a whole bunch of cellular functions, including reducing cytotoxic T cell and natural killer cell activation. It also increases regulatory T cell activity, which are like the brakes of the immune system. And they normally prevent overactivation, but in cancer, they're recruited to suppress cytotoxic T cells and natural killer cells. So the tumor keeps growing. So my answer is cancer cells use immunosuppression to evade the immune response?
Good answer.
That is correct. Okay, on to you, Neuron. We need one more.
The cancer cells, they're greedy. They starve the immune system because tumor cells compete with T cells for nutrients, oxygen, and amino acids. So the nutrient-depleted tumor microenvironment weakens cytotoxic T cell function so it can't fight cancer cells effectively. So my answer is cancer cells evade immune responses by competing for nutrients.
Let's see what the survey says. That's correct.
Yay!
Great round. So let's talk about how we can actually get rid of these guys.
You can't!
Well, science says otherwise. There's many ways, like surgery, chemotherapy, radiation, and immunotherapy. But these aren't always the most effective because cancer cells can adapt and develop resistance, making treatments less effective over time. Many of these therapies also lack specificity, meaning they can damage healthy cells and cause significant side effects. So, for our last and final round of the night, we surveyed 100 oncologists addressing one of the most promising therapies emerging in lung cancer treatment. The top 5 answers are all reasons why it's so promising. The question is, why are bispecific antibodies a promising novel treatment?
I'm gonna say it's because they bring cancer cells and immune cells together.
Alright, let's see if it's on there. And it is! On to you, sarcoma. Why are bispecific antibodies a promising new novel treatment?
It's because they activate immune cells to attack us, which sucks.
You don't seem too happy about that. Let's see what the oncologists have to say. That's correct. Bispecific antibodies will bind with surface proteins on cancer cells and on T cells at the same time. This brings them in close physical proximity while activating the T cell at the same time to release cytotoxic molecules that kill cancer cells. Melanoma, give me one more reason why bispecific antibodies are a promising new novel approach.
So they improve how effective the cancer treatment is, and so the combination of targeting cancer cells as well as activating the immune response makes bispecific treatment ahead of the game.
Let's see. There's another one on the board.
The clinical trials have been too effective. I lost the bloody online against a bispecific antibody.
What an exciting episode this has been. It's a pretty close tie.
No,
but
not for long. We got these bispecific antibodies on our side.
Looks like healthy cells won after all.
Good work, team.
Well, I didn't have a live demonstration on my agenda today, but I guess that's what the big takeaway for this episode. Bispecific antibodies have been generating so much excitement among the scientific and medical community because they don't just attack blindly. While other treatments like chemotherapy attack all cells in the body by attacking cancers faster, bispecific antibodies only attack cancer by recognizing specific markers on cancer cells while recruiting immune cells to the fight, helping the body's own defenses to find and destroy tumor cells more effectively. Of course, this isn't some miracle drug that can destroy all cancers forever, and a lot more research still needs to be done, but bispecific antibodies have been shown to be an effective therapy for non-small cell lung cancers, and adenosquamous carcinoma is most commonly present as non-small cell lung cancers. Thanks for joining us on Bodily Feud. I'm Stella Harvey, reminding you that when science brings back up, cancer better run. Good night, everybody.